All right, so we're wrapping up things now with our Unit 10, our final unit on oxidation and reduction. And the last big topic that we talked about is electrolysis, this idea that there are non-spontaneous processes that we can make happen through an input of energy. So let's look at some basics and also go a little bit more into the lab activity that we did in class today. So fundamentals here. You have to have a battery or a power source in order to make an electrolytic cell work. So you notice here we've got a symbol for a battery. That's in stark contrast to a galvanic cell, which actually acts as a battery. For an electrolytic cell, you've got to have something to push electrons in a direction that they wouldn't normally go. And in this case, you'll notice that we would be pushing electrons through the cathode into an electrolyte solution. Notice the nomenclature here is exactly opposite to what you might expect. Here, the negative electrode is labeled the cathode, and the positive electrode is labeled the anode. Now, for simplicity, what I'd suggest doing for us is just refer to the negative electrode simply as that. Call it the negative electrode, and over here just call it the positive electrode. That way you don't have to worry about getting jumbled up with anode and cathode components there for naming. So here's a picture of what we did in part 2 of activity 21 today. And if you remember, what happened was we had a solution here of copper sulfate. So fundamentally that means we have an aqueous solution where we have copper 2+ ions and sulfate ions. Now the sulfate's a spectator. It's not really doing anything in this reaction. What's happening is when we started to provide current, it means provide a stream of electrons, and if I just label this negative and positive here, this from the negative end of the battery we're pushing electrons through this graphite electrode. And that makes this whole negative area of the electrode, this would be our negative electrode, or our cathode in this case. Okay, our negative electrode would be here, and our positive electrode would be over here. You put it in the solution, and if you remember, the tip of this became coated with copper metal. And just as a refresher, what happened at that particular negative electrode was the following process right here. We had copper ions, which were in solution from the copper sulfate, being reduced to copper metal. Now the piece that we may not have had time to talk about, and it's actually pretty interesting, is what was happening at the positive electrode. Now you may have noticed that there was gas bubbles produced there. And what's fundamentally happening was we were taking water that was in solution, because it's an aqueous solution, and we were using water as our source of electrons. So we were causing water to be oxidized. Now specifically we were taking oxygen in water and oxidizing it. So we would get bubbles of oxygen gas, and we would get some hydrogen ions, and we'd get 4 electrons. So this process right here is what gave electrons to kind of go back through the battery and replenish the electrons that were being consumed here at the negative electrode. Okay? It helps us to understand what we saw in part 3. So if we take a look at part 3 just briefly. In part 3, depending on how you had the battery hooked up, and I just realized I think my picture may have been off, but we're just going to make it the way that it was in the lab. So we'll make this the negative end of the battery and the positive end here, which means our negative electrode would be the big paper clip right here. That's our negative electrode. And remember, when you immerse that big paper clip into the solution, again it's a solution of copper 2 sulfate, that copper plated onto the very tip of that paper clip. Now, fundamentally what was happening in this case was something a little bit different. In part 2, we didn't have a source of copper metal. In part 3, we did, because this wire here contains copper. This is a copper wire. So the copper wire was fundamentally being oxidized here and then reduced back onto the paper clip. And we proved this a number of ways. One is just we first initially observed the plating of the copper onto the paper clip. And then later on, when you reverse the polarity meaning you change the connections between the metal wire, the copper wire, and the paper clip, you notice that any kind of copper buildup that had formed on the paper clip would go away, and it would then be deposited onto the metal wire itself. So that showed us that fundamentally the battery was causing that plating. The battery was causing the metal to be plated, and it would always be plated at the negative electrode. So that's an overview. Make sure you guys read through the CK12 text tonight on electrolysis, and let me know if you have any questions or concerns. Have a great night, you guys.